Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at triangles. So the area of any triangle is base times height over 2. That's because you can start off with a triangle like this blue one here, and you can always draw a rectangle around it such that the area of the triangle, the area of blue, is exactly half the area of the rectangle. So here, the rectangle has area B times H, and so the area of the triangle is just half that, B times H over 2. So just note in measurement, whenever you see H, it always means perpendicular height. So here, the height perpendicular to the base, it never means slant height. So if we have a triangle with base 20 and height 10, you probably already know its area is just 20 times 10 divided by 2, and that gives us 100, and because dimensions were in centimeters, it will be centimeters squared. Okay, that's pretty easy. But what about the area of a triangle like this? See, the problem is sometimes we need to find the area of a triangle and we don't know its perpendicular height. Here we know the slant height but not the perpendicular height. And that's where Pythagoras' theorem can be really useful. So this sort of trick I'm about to show you only works for equilateral and isosceles triangle. If and only if the triangle is equilateral or isosceles like this one, what you can do is you can divide it perfectly in two. You can divide it into two what we call congruent right-angled triangles. So because this is isosceles, I know that this side here will be 4. And I can use Pythagoras to find the perpendicular height. So H is the shorter side of this black right-angled triangle. So it will be the square root of 12 squared minus 4 squared. We subtract when finding the length of the shorter side. So putting that on our calculator, we have the square root of 128. That's the exact length. Now, if you want to round it, I suggest using 4 decimal places, so it's about 11.3137. We want to use 4 decimal places, and that should allow us to get our final answer correct to 2 decimal places, because we have to use this number in the next step of our calculation. So we want it to be as accurately as possible. We don't want to round it to 11, because then our next step will be incorrect. So the area of this triangle, we can now use the formula up here, base times height over 2. So the area is just base, which was 8, times, I'm going to use square root of 128 because it's exact, base times perpendicular height over 2. So putting that in your calculator, you get about 45.25, and again, it's in centimeters squared. So once again, you can use this trick, use Pythagoras, when you have an equilateral or isosceles triangle for which you don't know the perpendicular height. What about the other type of triangle though? What about scalene triangles? Let's have a look at that. So let's look at this triangle here. This is scalene because each of its side lengths is different, 16, 22, and 28. So if I want to find the area of this triangle, unfortunately I can't use the trick from the last slide, because I can't divide this into 2 congruent right-angled triangles. See, this triangle here is clearly smaller than this one here. So the problem is, the reason I can't use Pythagoras to find the perpendicular height, I don't know how long this side is. It won't be 14 and 14 for a scalene triangle. These 2 sides won't be the same. It could be 10 and 18, it could be 11 and 17, we just don't know. So for that reason, we need another formula. We need another approach when we just can't find the perpendicular height. This formula here is called Heron's formula. It calculates the area of a triangle based on its side lengths. Its side lengths here are A, B, and C. S in this formula is A plus B plus C over 2. It's the semi-perimeter. So let's use this formula, Heron's formula, to calculate the area of this triangle when we know its 3 side lengths. So firstly, we'll calculate S. So S is the sum of all the side lengths divided by 2. It's the semi-perimeter. So here, 66 divided by 2, which is 33. So the area of this triangle will be the square root of s times s minus a. Note here it doesn't matter which sides you call a, b, and c. I'll just go a, b, and c. So 33 minus a times 33 minus b times 33 minus c. So what we can put on our calculator, it'll be the square root of 33 times 17 times 11 times 5. So putting that on our calculator, we get 175.66, and it will be centimeters squared. So this formula is very useful for scalene triangles, but we can also, if it's isosceles or equilateral, calculate the perpendicular height if we know all of the side lengths. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.